In this video, I'm going to show you how to factor polynomials using different methods, depending on what pattern they may follow. In this video, for part 1, we're going to look at only binomial polynomials. Okay? So, two terms. Now, first, you always check for a greatest common factor. Do that first before you do any of the problems. So x squared minus 9, no GCF, we're good. Now, the first pattern I'm going to show you is a difference of squares. If we have two numbers that are perfect squares being subtracted, if we square root both numbers, we can add and subtract those to get the factors. So square root of x squared is x, the square root of 9 is 3. This means I can write this as x plus 3 times x minus 3. And that's all you're doing. Now if you have more than one, if you got a number in front of your variable, it's still the same process. So I'm going to start by square rooting the first term, 16x to the 4th. Now x to the 4th is a perfect square, just like any even exponent. Basically you divide the exponent by 2. So square root of 16 is 4, square root of x to the 4th is x squared. For my other term, I'm going to take the square root of 25 to get 5. So I'm going to write this as 4x squared plus 5 times 4x squared minus 5. And this is this expression factored out. Now, you do have to make sure that when you factor, that your factors can't be factored further, like on this next one. Start with the GCF, which we have on this one. I'm going to divide both terms by 10w, which leaves me with w to the 4th minus 1. Then I'm going to use the difference of squares to factor this. Now the 10w stays put, I haven't gotten rid of it, I just carry it with it. And then I square root both terms, add and subtract them. So w squared plus 1 and w squared minus 1. But the thing is, the w squared minus 1 is also a difference of squares. So I can continue factoring. The 10w, w squared plus 1 carries over. I'm going to bring that down. And now I'm going to factor this out. Square root both terms, add, and subtract. And this is this expression factored all the way out. Now another binomial pattern that you might see is the sum of cubes. This is where both terms are perfect cubes. You'll cube root both terms, both numbers, and then plug them in here. Now, this one here, at first, doesn't look like a difference of cubes until I check for a GCF, which there's a 2. So this can be written as 2x times x cubed plus 27. And x cubed plus 27 is a sum of cubes. Now, the cube root of x cubed is just going to be x. That's my a term. For my b term, I do the cube root of 27 to get 3 for my b term. And now I plug them in here. The 2 I'm bringing over. A plus b, so x plus 3. A squared, so x squared, minus a times b, so x times 3 gives me 3x, plus b squared, 3 squared is 9. And one good thing about the difference or sum of cubes is that once this is factored, you're not going to be able to factor further. So there's not going to be any issues like on this problem where you have to continue. Sum of cubes, factor it, you're done. This one, 8x to the 6th plus 1, these are sum of cubes without having to look for a GCF. Now, anytime you have an exponent that's divisible by 3, it is going to be a perfect cube. Basically, you're just going to have to divide the exponent by 3. So, for instance, if I take 8x to the 6th and cube root it, I'm going to get 2x to the second, because 6 divided by 3 is 2. So that's my a term. For my b term, cube root of 1 is 1, so that's b. I'm going to bring it over here. So a plus b, 2x squared plus 1. Then I have a squared, which would give me 4x to the 4th, because I squared this term, minus a times b, so multiply those to get 2x squared, and then b squared, well, I'll square 1 to just get 1. And again, once that's factored, you're done. Now, this also works even if there's variables in both terms. So here, there's variables in both terms, but they're both perfect cubes, as is 216 and 125. So, doing that first. So 216 is, if I cube root that, I'm going to get 6. Cube root of x cubed is just going to be x, so that's my a term. For my b term, I cube root 125 to get 5, and y cubed to get y. And now I can go ahead and plug those in. So, let's see. Okay, so a plus b gives me 6x plus 5y. Then there's a squared, so 6x, and I square it to get 36x squared, minus a times b, so multiply these together to get 30xy, plus b squared, so I take 5y and square it to get 25y squared. And again, sum of cubes, once you do that, you can't factor further. Now, difference of cubes. I did not write down my problems. I should probably do that. Okay, so let's start with 64 minus x cubed. Now, the difference of cubes is pretty much the same exact process as it was for the sum of cubes. The only difference is your signs here and here are switched. Alright, so let's take a look at this first one here. Cube root of 64 is 4. Cube root of x cubed is 8. So that's my a and b terms. So a minus b. So 4 minus x. Times a squared. So 4 squared gives me 16. Plus a times b. So multiply these together to get 4x. Plus b squared. So I take the x and square it. And I'm done. That's as factored as it's going to get. Now this one, they are both perfect cubes, as it is written right now, but there is a greatest common factor. You always want to start by taking out the greatest common factor. It actually makes your number smaller and easier to work with, even if both fit the pattern. They're both divisible by 8, which is going to give me 64x cubed minus 1. So for my a term, I'm going to cube root the 64x cubed to get 4x. And my b term, cube root of 1, is 1. Now the 8's not going anywhere, I'm still going to keep that. But now I'm going to use the 4x and the 1 as my a and b's to plug in here. So a minus b, 4x minus 1, and then a squared, so 4x, and I square it to get 16x squared, plus a times b, so multiply these two terms to get 4x, plus b squared, so I'm square 1 just to get 1. And this is as far as I can go on this one. Alright, so part 1 here, we looked at just binomial patterns. In part 2, we're going to look at how to factor when there's 3 or even 4 terms.